When a massive blue giant star exhausts its nuclear fuel, its core can no longer support its own weight. In a fraction of a second, the star rapidly collapses inward, leaving behind a pitch-black spherical void that heavily distorts the starlight around it. We are going to trace a path directly across that absolute boundary. We will follow matter as it falls past the point of no return, down into a realm where the known laws of physics cease to function. A black hole is the remnant of a dead star, where gravity has won the ultimate cosmic battle, crushing matter with such force that no other physical interaction can resist it. To understand the extreme limits of nature, we must journey directly into the most destructive and isolated environment in existence. We have observed the immediate exterior of these objects. This is the supermassive black hole in M87, showing a glowing orange ring of superheated gas that outlines a central shadow of absolute darkness. This shadow exists because the black hole's mass warps the fabric of spacetime so severely that light cannot travel in a straight line. As beams of light approach, they are violently bent around the void and hurled back into space. This warping also affects time. To an outside observer, an object falling toward the center appears to slow down as it approaches the edge, redshifting until it eventually freezes at the horizon and fades from view. This is the event horizon, the mathematical boundary where the velocity required to escape the gravitational pull exactly exceeds the speed of light. Crossing this line severs you from the observable universe forever. The interior is an isolated reality, physically disconnected from our own. As you fall past the horizon, your view of the outside universe shrinks to a tiny point of light behind you. Space-time grid lines stretch and warp until they snap into pure darkness. General relativity, the framework pioneered by Albert Einstein, predicts that all matter inside this region is pulled toward a single, inescapable center. Einstein's math leads to a singularity. This is a point of infinite density, where matter is crushed into zero volume and the force of gravity becomes infinite. Within this region, the directions of space and time effectively swap. Moving toward the center is no longer a choice of direction. It is a timeline arrow pointing only one way. This singularity is a mathematical dead end. Here, our descriptions of gravity collapse into infinite values, and our ability to predict reality disappears. In the 1970s, Stephen Hawking introduced a new complication by proving that black holes are not entirely black. He discovered that quantum effects cause black holes to leak radiation, losing mass over trillions of years until they evaporate completely. If a black hole evaporates to nothing, it creates a crisis of information. Matter with specific properties falls in, but the black hole eventually vanishes, leaving behind only featureless particles of radiation. This pits the two pillars of physics against each other. Quantum mechanics requires that information is never lost, but relativity suggests that information is deleted by the singularity. The information paradox forces a difficult conclusion. At least one of our foundational theories of the universe is incorrect. Modern physicists are attempting to resolve this conflict by proving that the singularity does not actually exist. String theory proposes the fuzzball model. In this version, the interior is not empty space leading to a point, but a dense, three-dimensional tangle of fundamental strings that preserves all the information of the matter that fell inside. Loop quantum gravity offers a different solution. It suggests that space-time is made of finite, interlocking loops. Because these loops have a minimum size, they cannot be compressed into a zero-volume point. As matter collapses, the loops compress until they hit a fundamental limit. The core then rebounds against the force of gravity, like a compressed spring. These models suggest the center of a black hole is a chaotic and vibrant new state of matter, rather than a final end to reality. Some theories suggest that the extreme compression inside a black hole could puncture the fabric of space-time entirely, opening an Einstein-Rosen bridge to a different region of the cosmos. Physicist Nikodym Poplavsky utilizes the concept of space-time torsion to show how gravity could trigger a massive expansion rather than a total collapse. In this scenario, the matter falling into the black hole reaches a critical density and then bounces outward, triggering a brilliant explosion of new space, a baby universe forming inside the black hole. This model points to an unexpected lineage for our own origin. Our Big Bang exhibits the exact mathematical signature of a white hole, the exit point of a black hole formed in a higher dimensional parent universe. These black holes may function as generators of new space, the infinite engines of creation spawning a nested multiverse.